So they ask for the mole of, they say the mass is 15 grams, and they say of water. Now the reason why they give you water so that you can calculate its molar mass, which is 18. Okay, so you have mole is mass over molar mass, so that's 15 divided by 18, and if you calculate that, what do you get? 0.83 moles. Okay, question B. Yes, Mama. $87. No, you should get 8.33 times 10 to the power negative 1. Type it in your calculator again. Right, question B. Pongani, where's your work? Where's your book? Again, you forgot it at home. Tomorrow, I want to see your book. With all the homework. Copied.
I can even shoot for you today.
But your book is at home. But you want to show it today. No, I want to see it with my eyes. Alright, question B, they ask what is the mass? They say the mole there is 0.05, and they say you have Na2O. Bongani, what is Na2O's name?
Sodium oxide.
Yes, don't scream out, then he hears sodium oxide, and that gives you 40, 50, 60, 62. Alright, so mole is mass over molar mass. Mole is 0.05. We want the mass, and the molar mass is 62. And you get there what, Antoinette? 3.1 what? Correct. Okay, question C. They ask you, what is the number of ions? Okay, now this one gets more complex. Number of is capital N. The number of, and they want specifically the ions. And they say the mass there is 10 grams, and we have MgCl2. What is the name of that compound, Declan? Chlor? I couldn't hear?
Chloride.
With a what at the end? DT? D. Chloride. The reason why they give you that, so that you can calculate the molar mass, which is 24 plus 71, and that gives you 95. Okay, now they ask for the number of ions. That formula you find there, the number of ions over Avogadro's constant. If I check, see, that is what they want. Avogadro's constant is a constant that will be on your data sheet, so you need the mole. They did not give you the mole, you have the mass and the molar mass. Okay, so you must first, with the help of the mass and the molar mass, go calculate or determine the mole. So that will be 10 divided by 9.8. Bookie, if you calculate that, what do you get? Ooh, it is 95, not 9.5. It's not your final answer, so don't round off just yet. 0.10526, blah, 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 blah. Okay, so that is the mole. What was the question? The question was the number of. So then now we're going to take that formula. N is N over Na. So the mole is 0.10526. We want the number of, and that is Avogadro's constant that you'll find on your data sheet. So you get the number of to be what? Ti amo. Mm-hmm. Okay, it's not your final answer yet. 3368, yes. That's what I got, but it won't make a big difference. Yes, times 10 to the power of 22. Okay. Now that there, what you've calculated is the number of molecules. Okay? Because you used the mass of the molecule and the molar mass of the molecule. But they didn't ask the number of molecules, they asked for the number of ions. So you have to go write down the dissociation reaction, where you say magnesium chloride in the presence of water splits up to form magnesium ions and 2 chlorine ions. Okay. Now, if you look at the question, and I hope you have the question open in front of you. If you look at the question, it asks, what is the number of ions? Do they say which ions? No, they say all the ions. So here we see that one molecule gives us 1 plus 2, 3 ions. So not specifically what ions, just in general, ions. So one molecule gives 1 plus 2, 3 ions. So if that is how many molecules we have, then we are going to multiply that by 3 to get the number of ions. You're going to say 3 times that. And then you get it to be 1.90 times 10 to the power 23 ions. So if you were grade 10, this question would count 6 marks. But this is still preparing you for grade 11 work.
So we wouldn't get it.
The chances that you'll get a question like this is slim. Yes. Okay, can I go on?
Yes.
Right, then you had to do question 3. Yes. Okay, so question 3, I asked there, prove that 0.2 moles of chlorine gas and 0.2 moles of methane gas have the same volume at STP. Okay, so we need to prove that they have the same volume at STP. So we have the mole is 0.2 of chlorine, and we have the mole is 0.2 of methane. They tell you we're at STP. What does STP stand for?
Standard temperature and pressure.
Yes, and if they say that, you're allowed to use what, Kumo? VM, that is 22.4. So what they're basically just telling you is that the volume for these two are the same. They're already telling you that. Now they ask you, prove that they have the same volume. Okay, I'm going to do this the long way, and I'm going to do this the short way. If you do it the long way, then you are going to have to go calculate the volume. So this is 0.2 volume times 22.4, and you get the volume to be what? You get it to be 4.48. Ne? And this one moles, volume over volume at STP, 0.2, volume 22.4, and you get the volume to be 44.8, and you see, all right, they are the same. You've proven they are the same. What's wrong? Ah, man. Lucky. Or there's a shorter way. Now, why do I explain the shorter way? Is this is more a multiple choice type of question. So more a concept that you must understand. Okay, so the concept that you must understand is the following. If they say you are at STP, or if they say you are at the same temperature and pressure, then it means the volume, the molar volume for the two will be the same. 22.4 or 20 and 20 or whatever. Okay, then according to this formula here, if this is the same for both of them, then you must understand that the mole is directly proportional to the volume. Directly proportional means if the one gets bigger, the other one gets bigger. If the one gets smaller, the other one gets smaller. So since they have the same mole, since the mole of chlorine is equal to the mole of methane, it means the volume of chlorine will equal to the volume of methane. So you didn't even have to do a calculation. You can just say, since that is the same, we can say they're directly proportional to one another. So since that is the same, that will be the same. That is also sufficient proof, enough proof. Any question, anything I must say again? Going on. Why are you guys so quiet? Of what? I see. Okay, next one. Question 4. Did I say you must do that? Yes?
Yes.
Okay. So question 4 is also a similar type of question. Also a good multiple choice type of question. Good. Okay. So at question 4 they ask, which one has the biggest volume at STP? 5 grams of nitrogen gas or 5 grams of oxygen gas? Okay, so again they tell you you're at STP and you know that the VM will be 22 for both of them, 22.4. Now they tell you the mass is 5 grams of nitrogen gas, Jabu. What is the formula for nitrogen gas? If you didn't know that, you couldn't answer the question. Jabu. Nitrogen gas, the formula. What is nitrogen? What is the symbol for nitrogen? And look on the periodic table. Where does N sit? There at number 7. Starts at number 7. It's part of 7 special molecules. That makes a 7 on the periodic table. What are those 7? No, she mustn't name them. The nitrogen is part of what group of molecules? That it's not just N. Here's Bookie. Diatomic molecule. You had to know that nitrogen is N2. Yes, Jabu? Okay. Then Tawana, the other one is oxygen gas. What's the oxygen symbol? But it is part of that 7. So it is. So what does it look like? Oxygen gas. O2. This is something from grade 10 that I expect you to know. Okay, so nitrogen's molar mass will then be 2 times 14, which will give you 28. And oxygen will be 2 times 16, that gives you 32. Okay, and you have to prove which one has the biggest volume. Okay, at STP. So to calculate volume is mole is volume over volume at STP. So if we have that, and we need to calculate the volume, then we must first get the mole. For mole, we need the mass and the molar mass. Okay, so you can, for both of them, just write mass over molar mass is equal to mole is equal to volume over volume at STP. Okay, so you can do it in 2 steps or 1 step. You can either first go calculate the mole and then go calculate the volume, or since they are equal to one another, you could have also just rearranged it and said volume is mass times molar volume over molar mass. So I just rearranged it. Okay, then if you calculate it, the volume for nitrogen would have been 5 times 22.4 over 28, and the volume for oxygen would have been 5 times 22.4 over 32. Okay, Mama, you're calculating the first one for us, and then Liaok with the second one. So 4. Okay, and Liaok with the next one. I just get 3.5. You get 3.58. Type it in again, I get 3.5. Okay, maybe you just was late at night, or it was break time and someone spoke to you. All right, so from there we can see, okay, which one has the biggest volume? Okay, it's that one, so the answer is nitrogen gas. Or you could have done it in a shorter way. Okay, so this is calculating it for both of them. Or, I just don't have space below, you can write below or next to it. Or you could have said, all right, I see here that if I want to get the volume, I must have the mole and the molar volume. Since I'm at STP, they will have the same molar volume. So I can just say that mole is directly proportional to volume. So the one that has a bigger mole will have a bigger volume. Okay, now I have to determine the mole. If I look at this formula, mass over molar mass, I see that both of them have the same mass. They are both 5 gram and 5 gram. So it's like the mass stays constant. So from that I can get that the mole is inversely proportional to the molar mass. Okay, so from there, Jobber, you must listen. From there you can derive the following. The one that has a bigger molar mass will have a smaller mole. And the smaller mole will have a smaller volume. Are you with me? Okay, but they will ask which one has a bigger volume. So if it has a small molar mass, it will have a big mole. Big mole will have a big volume. So between the two, which one have a smaller molar mass? It is nitrogen. Okay, so from there you can just say nitrogen. So you can either do calculations or you can use formulas. Okay. Then I said you can skip number 5. Yes. Then we're at number 6. Okay. Number 6, they ask you what is the mass of sodium hydroxide. Bongani, what is sodium hydroxide's formula? Sodium hydroxide. And I think they say the concentration should be 500 and the volume is 500 milliliters. Sodium hydroxide. Is it 500 or is it 3?
500.
Yo, ma'am, I don't know.
No. That's not what I want to hear. Sodium hydroxide. No. Sodium symbol.
NA.
Na. What's the valency for sodium? Say again? No. 1 plus 1. What is hydroxide? It's not on the periodic table. Okay, you can help him with hydroxide is OH minus. So, Mungani, sodium hydroxide, the valency is fit. So what will the formula be? You don't write the one? Sodium hydroxide. Okay, the reason why they give you that is so that you can calculate the molar mass, and I'm telling you it's 40. Okay, so it is concentration is mass over molar mass times volume. The concentration is 500. We want the mass. The molar mass is 40. And now the volume. They give us the volume in milliliters. Milliliters is the same as centimeters cubed. We do not want it in that. We want it in liters or in decimeters cubed. Antoinette, what are you going to do? Yes, or times 10 to the power negative 3 or divide by 10 to the power 3, and that gives you 0.5. Alright, and Declan, if you calculate that, what do you get? $10,000. That's massive. 10,000 what? Okay, and Bookie, it wasn't the question, but I'm asking, how many kilograms is that? 10 kilograms. Okay. Then, did I give you question 7? 7 and 8?
8.
Not 7, okay, only 8. Okay, 8 was again easy peasy. Yes, the first one they asked, give the empirical formula for, and then they say glucose. Glucose is a sugar, type of sugar. That is the molecular formula for glucose. Tell me, what will the empirical formula be? This will count 1 mark. It's no big calculation. It will be... Shh. It's not C3. Yes, Siamo? Say again? 6. What? No, don't plus anything. I'm just going over the shock of everyone getting this wrong. Okay, wait. Selma, I want you to understand. Do you want to try or must I first explain? I said yesterday in class, I said if we look at men versus women in this class, we had 3 men versus 9 women. So it's men 3, women 9, and I said we can get the simplest ratio, then we would say it would be men, women 3. You remember that?
Yes.
Okay, use that information to get the empirical formula for that. Yeah, it's not difficult. Like I don't know. Did you understand what I explained? Okay. So empirical is the simplest ratio for that. What is it? Shh.
Don't laugh at us.
I'm not laughing. I'm crying. Siamo. Okay, Antoinette, please. Antoinette, still wanna.
I'm just trying, I'm not sure. It's H2O.
Yes.
Yeah?
Ganja.
Can you see this? The biggest common factor is 6. You divide by that. Yeah. Okay. Ooh, 8A. 8B. Stiamo is again. I'm gonna do you. Carbon dioxide.
So what happens?
And can I have it and she'll have number C?
Yes.
Isn't it CO?
No.
CO2, man. It stays the same.
It stays the same. You can't divide by anything more. Because you can't get something like C a half O. If you divide by 2, then you'll get a half. That's not right.
Number C going to.
Okay, number C, Tiamo. Is C2H2. What will that be? Nish. Tiamo. Where do you get the 4 from?
Maybe it's confusing this way.
Isn't it confusing me? Alright, okay, that was all homework, ne? Okay, let's go back. Alright, we are busy looking at this balanced equations. Okay, right. And now we're going to go to a concept that I've discussed a bit before, but I'm going to discuss fully again. So we're on page 10. If I'm not mistaken. Okay, you don't have to write this down. You can if you want to, but you don't have to. Okay, let's say you want to invite friends over, I don't know, to watch a movie or whatever, and you decide you're going to make them sandwiches. Just cheese sandwiches. Okay, right. So, how do you make a cheese sandwich? You need 2 slices of bread. I'm going to just write 2 bread. Okay, you know what I mean with slices. 2 bread. You're going to need 1 slice of cheese. And that gives you 1 sandwich. Okay, right? Are you with me? That is your ratio. Okay, now you go buy a loaf of bread. How many slices are there in a loaf of bread?
16.
Is it 16? With the sides? I think there's 18. No, not a dozen. In my head. Okay, alright. We're going to go with the first number I heard, 18. So you go buy a loaf of bread, and the loaf of bread has 16 slices of bread in it. Then you buy, we're going to just make it in our head. You've seen that cheeses that has a plastic around it, that block, like small slices of cheese. That's so expensive and it doesn't taste like cheese, it tastes like plastic. Okay, you buy that, and in that packet, let's say there's 10 in a packet. Okay, 10 slices of cheese. That you have bought now at the shop. Have you made any sandwiches? No. So you have 0 sandwiches to start with. Okay. Now, are you just going to throw all of the bread and all of the cheese together? No, because you must ration it, right? And it says 2 and 1, 2 and 1, 2 and 1. All right. So if you use all 16 slices of bread, how many slices of cheese do you need? 8. Because 2 slices of bread needs 1 slice of cheese. So you need 8 slices of cheese. So then we'll say we have too much cheese. We will say we have excess cheese. Oh, I can do it the other way around. I can say if I use 10 slices of cheese, how many slices of bread do I need? 20. So you can see I don't have 20 slices of bread, so I have limiting amount of bread. Okay, right, so what we would have done is we would have used all our bread, we would have used 8 slices of cheese, and then how many sandwiches would we get? 8 sandwiches, so then you have 8 sandwiches at the end. Okay, now this here, where we use all of it, that one that was the limiting, we call the limiting reagent. Okay, and the one there that we have too much of, we call the one that is in excess. Okay, so that is what we're going to look at now. Can I page? Okay, so it says there, when reagents are not present in stoichiometric quantities, we said stoichiometric means the perfect amount, we use everything. Then one reagent is in excess and the other reagent limits the quantity of products that will form. We use the mole ratio to determine the limiting reagent. And then the limiting reagent will we use to calculate the quantity of products that will form, how many products will form. You'll see I use the abbreviation LR for limiting reagent. It's not an official abbreviation, it's just one that I use because I'm lazy. Okay. These equations that I give as examples, and those that you'll get for homework, they are all reactions that you need to be familiar with in a test or an exam. What do I mean familiar with? When you see it, you should not have seen it for the first time. And I do expect you to answer a few questions regarding this. Okay? Like for example, what is this one's name, Kumo? Say again. Ammonia. Ammonia. This one, Jabu? Oxygen. This one, Tawana? Nitrogen. How many oxygens are there? So what do we call it? Monoxide. Nitrogen monoxide, a poisonous gas. And this one, Mama, easy peasy. You guys.
Mama.
Yes.
Would it be wrong if nitrite?
No, nitrite is an ion. Nitrite looks like this. It's a nitrite ion. So yes, it would have been wrong. Okay, right. So there you see they give you a balanced equation. 4 to 5 gives you 4 to 6. Now they say if 1 mole of ammonia is added to 2 moles of oxygen at STP conditions, yay, Vm is 22.4, then calculate the following. Okay, now in a test or an exam, before you calculate anything, you are going to start with your mole table. Okay, let's go over the mole table again. You first write down your balanced equation. You don't have to fill in the phase subscripts, just your balanced equation. And then just underneath that, you are going to write down your mole ratio. So 4 to 5 gives me 4 to 6. Okay, so that is your mole ratio. You take your highlighter, you highlight that a different color to indicate to yourself, I must remember that that is just theoretical, or that is just my recipe. Ooh, how do you spell recipe? Recipe. Sue. Yo, am I right?
Yes.
Wow. So that is just my recipe. It's not what I have. Is you open your book and that's what the book says. Okay, now I'm going to start with my beginning value, my change, and my end, and I put in my arrows. Okay, let's see. They tell us you have 1 mole of ammonia and 2 moles of oxygen gas. So I have 1 mole of ammonia and 2 moles of oxygen gas. So that is like opening your cupboard or opening the lab there at the back and checking how much do I have. Do you have any products yet? Have you added them together? No. So this will always be 0 and 0. Always at the beginning. Okay. Now we must check. Am I going to write -1, -2 to give me 0 and 0? No. I need to figure out if I use 1, how much of that will I use? It's like the bread and the cheese. Okay. So I'm going to do this slowly. You're going to see I'm going to move faster as we go on. I'm going to do it slowly. I'm going to first write 4 ammonia versus 5 oxygen. So the mole ratio is 4 to 5. Okay. But I don't have 4 ammonia. I only have 1 ammonia. So you write down 1 and then you draw a line and you stop. So you don't fill in the 2 there just yet. Okay, you ask yourself here, if I use all of this 1, if I say -1, how much will I minus there? Is it 2? Is it 1? Is it 4? Is it what will I minus? Okay, so what do we do from the left side to the right side there? Divide by 4 times 5. What you do there, you must do there at the bottom. So 1 divided by 4 times 5. Liakwe, we're back with you. Gives us what? Should be easy. You say with your calculator in front of you. Yes, Liakwe? 1.25. Okay, so you check now. You say, if I use that 1, so if I write -1, how much will I need? Do I need 2? Do I need more? Do I need less? I see I need 1.25. So I see I have more than enough. I have 2. I only need 1.25. Okay, so from there, I'm going to write there 2. Because I'm just going to check. I need 1.25. I have 2. Check. I have more than enough. So from that, I derive this one is in excess. I have too much of it. I only need 1.25, but I have 2. And this one here is my limiting reagent. It's the one that I'm going to use everything of. Okay, I'm just going to show you. You can do it the other way around as well. You can swap the 2. You're going to say 5 oxygens versus 4 ammonia. So I'm just swapping them around. So it's 5 versus 4. But I don't have 5. I only have 2. So I'm going to fill that 2 in there. I'm going to say, right, 2. If I use the 2, how much of that will I need? Okay, so I'm going to check again. What do I do from the left to the right? Here, I'm going to divide by 5 times 4. Divide by 5 times 4. Yes, Bongani. $1.6. So now you go check. If I use all of the 2, how much of that will I need? I will need 1.6. How much do I have? 1. So I only have 1. Is that enough? No. So if that's not enough, it means it's my limiting reagent and the other one is in excess. So we prove the same thing twice. Right. Okay, now the one that is your limiting reagent. Okay, you're going to see I'm highlighting this block there. That is my limiting reagent. There is two things that you must remember regarding your limiting reagent. Okay, so two things you must remember. Number one is you use all of it. Meaning, if there's a 1, you say minus 1 so that you have 0 left at the end. So you use all of it. So that you have nothing left at the end. And the second thing that you must know is the limiting reagent determines the number of products. Remember, hashtag stands for number of. Hashtag was not originally made for Twitter and Instagram and TikTok. And. Do you guys do TikTok?
Why were you quiet them after treatment?
Why? I'm always quiet.
You're always angry.
What?
Why were you angry?
At what?
After treatment, the time was treatment. We went to you, man. You were so serious.
I'm always like that.
No. I can see you when you're not okay.
Ah, Bongani. Ask Antoinette why I was upset.
Hey, problem, child.
I had a conversation with Antoinette. I was focused. It's between me and her. It's a secret. Alright. So, important. You determine the limiting reagent. That which is the limiting reagent, we use all of it. And that will determine how much will form or will be used going further. Okay, so we saw that if we use the 1, then we will use 1.25. So there we're going to write minus 1.25. So we had 2, we subtract 1.25. So we have left 0.75. Okay, then this will determine how much will form. Okay, so if this ratio is 4 to 4, but I don't have 4, I have 1. How much will form here? 1. So you're going to say plus 1. Okay, so you had 0, you added 1, so you have 1 left. Okay, so quickly want to stop. The first question there was, which gas, is that your cell phone or is it my cell phone? It's mine, apologies. Okay, the first question was, which gas is the limiting reagent? And we determined it was ammonia as a limiting reagent. Okay, ammonia. Then, what is the mole quantity of nitrogen monoxide that forms? So they want to know how much forms there. Now, if you do it in your table, in grade 12, you're going to do it in your table, and you're going to get about 7 marks for your table. In grade 11, you can either do it in your table or you can explain it. Now, since we've already done it there, you can just write, so this was question A. As question B, you can just write, refer to the table, meaning, look there, I've done it in the table. And we got the mole of nitrogen monoxide to be 1 mole. Okay, then at question C, they'll ask you, I'm going up. At question C, they ask, what is the mole quantity of water that forms? Okay, now again, you can either do it in your table, but this mole ratio is a bit difficult. It's not just 4 to 4, like this one was easy. It is 4 to 6. Okay, so I'm going to do it slowly with you. So we have 4 ammonia versus 6 waters. So it's 4 to 6. Okay, but I didn't use 4. I used 1. Okay, so I'm going to write down 1. And I want to know how much will form. Okay, what did I do from here to here? Why do you want to make it so complex? she's doing something. So that gives you 1.5. Yeah, I know, but you always do it a bit different. But it's fine. Okay, so you can see there, that gives you plus 1.5, so you have 1.5 there. Okay, right. So you can either do it in the table or you can show it step by step like that. Now they ask at question D. There's someone walking. No. Your homework? Yes. For today, I'll give you not a lot. For today, you do number 9 and number 10. Number 9 and number 10.
And 12 for 11 and 12.